Welcome to this explainer. Today we're diving into one of the absolute grandest mysteries out there in the night sky, our accelerating universe. We're going to look at this through a deeply fascinating conceptual framework known as General Emergence Mechanics, or GEM, to tackle the whole dark energy problem. Now, we aren't here to just throw out standard cosmology. Instead, we're looking to reframe how we see the cosmos in a completely new way. So let's get right into it.
Okay, you probably already know the timeline, but let's quickly trace it back. Pre-1998, right? The standard assumption was that gravity was basically acting as a giant cosmic brake, slowing down the expansion of the universe. But then, bam, 1998 hits. Supernova data completely flips cosmology on its head. The expansion wasn't slowing down at all. It was actually speeding up. So, to account for this silent, massive acceleration, standard models had to introduce an unknown driver. And we called it dark energy.
And the sheer scale of this is exactly why the mystery is so profound. To make the math of an accelerating universe actually work, this totally unknown component has to make up nearly 70% of our cosmos. Think about that for a second. 70% of the universe is just this massive, silently accelerating void, governed by something we literally cannot see and really don't fully understand.
To this day, we still don't know what dark energy physically is. Standard cosmology is kind of left grappling with placeholders. Like, is it a cosmological constant? Is it vacuum energy from the quantum jitter of empty space? Maybe some new unmapped field? Or is it proof that gravity itself needs modifying on cosmic scales? The observational data we have is absolutely incredible, but the physical reality? Well, that remains a profound unknown.
So, because gravity naturally pulls matter together, it makes total sense that when we look at an accelerating universe, we ask the standard question, what massive force is aggressively pushing the universe outward? If things are flying apart faster and faster, our intuition says, well, something's got to be pushing them, right? It's a very mechanical way to picture the problem. We instantly imagine a force, some hidden substance, or a repulsive energy just driving galaxies away from each other. But what if we're asking the wrong question? Instead of just asking what's pushing, the General Emergence Mechanics, or GEM framework, asks something profoundly different about our cosmic geometry. What if we are totally misreading a fundamental law? What if, instead of asking what is pushing, we ask, what is relaxing? Now that completely flips our perspective, doesn't it? It invites us to consider that dark energy might not be the universe being violently pushed apart, but rather the universe attempting to find a state of relaxation. And this right here perfectly illustrates that paradigm shift. On one side, we have the traditional mechanical imagery of standard cosmology, this aggressive outward force pushing space apart, almost like debris being thrown outward from an explosion. But on the other side, the GEM interpretation gives us something else, a passive relaxation of a live geometric field. We're moving away from the idea of disconnected objects violently repelling each other in some empty, dead void. Instead, we're considering a continuous, interconnected universe that's actively adjusting itself to lower its overall coherence cost. To really wrap our heads around this geometric shift, we first have to totally reframe how we see matter itself. In the GEM framework, matter isn't separate from space. We really have to stop picturing disconnected objects just sitting passively inside a big, empty box. Instead, matter is localized curvature. It is a stable, high-density, highly twisted region of structure inside a continuous cosmic coordinate field. Everything, you, me, the planets, the stars, we are intensely twisted regions within a live, continuous geometry. Now let's think about how this evolves across the cosmos. As gravity goes to work, it gathers this localized curvature into increasingly dense basins. First, matter gathers into stars. Then, those stars bind together into massive galaxies. And finally, those galaxies pull together into incredibly dense clusters and compact objects. And with every single step, the local geometry of the universe gets deeper and far more constrained. The field is literally being twisted and pulled into these intense local concentrations. And here's the absolutely crucial point. The universe pays a heavy curvature cost for gathering all this matter. The sharper the local gradients, meaning the denser those stars and galaxies become, the greater the twisting burden on the universe. Just imagine tightly twisting a piece of continuous fabric. Those deep local wells create immense tension. This gathering creates a profound curvature cost, and that intense local tension absolutely has to be balanced out by the rest of the continuous system. Which brings us perfectly to the GEM reframe for the dark background between these dense matter basins. That vast space stretching between galaxies,
It isn't just dead emptiness. It is a live geometry, a continuous coherence field that absolutely must maintain global stability. As those matter basins get deeper and more twisted, the surrounding field has to balance the cosmic books. It has to preserve the global conditions that allow the entire structure to exist. And how exactly does it do that? Through what Jem calls persistence pressure. I just love the poetic cosmic balance of this. Gravity gathers matter into depth, and persistence pressure relaxes the background field. When you look at it this way, dark energy is definitely not some magical fluid or a mysterious invisible substance. It's simply persistence pressure. It's just the natural, geometric response of the cosmos, trying to maintain its equilibrium while gravity twists up local pockets of matter. You can really think of it as the ultimate balancing act. On one side, gravity creates deep local structure, twisting the field into these really sharp constraints. And on the other side, persistence pressure acts as the passive relaxation response, stretching and flattening that vast background field. So one creates local tension and the other enforces global coherence. They're literally just two sides of the exact same geometric coin. Now, let's be super clear about what this interpretation completely removes from the board. We are entirely discarding that aggressive mechanical imagery. Persistence pressure is not a repulsive fluid. It's not an aggressive outward force shoving galaxies apart. It's definitely not explosion debris, a hidden substance, or some kind of cosmic wind. We are moving entirely away from the idea of a universe that's just being violently blown apart. And this logical framing elegantly solves our expansion picture. Bound systems remain bound, the local depth of gravity holds firm, so stars stay safely in their galaxies, and galaxies stay tightly held in their clusters. They aren't being ripped apart from the inside. Instead, it's only the vast empty background between these unbound, large-scale structures that actually stretches and expands. Therefore, the acceleration we actually observe, the data we get from those distant supernovae, is simply the visible signature of the universe negotiating the immense cost of its own coherent structure. The cosmos expands because the background coherence field is still relaxing across the largest possible scales. The universe isn't running away from itself. It's honestly just flattening out the vast empty spaces to compensate for the deep, tight twisting of the galaxies. What's really cool is that this elegant reframe also provides a fascinating lens for the cosmological constant problem. As you probably know, this is one of the deepest failures of scale in modern physics. I mean, we're talking about that massive, totally unresolved mismatch between the enormous theoretical energy of the quantum vacuum and the incredibly tiny dark energy effect that we actually observe in reality. Well, the GEM interpretation neatly separates this problem into two completely distinct categories. On one hand, you have the raw vacuum possibility. That's the massive theoretical energy jitter predicted by quantum theory. But on the other hand, you have persistent geometry. That's the actual, tangible structure that manages to become globally admissible. Basically, raw possibility is simply not the same thing as persistent geometry. And through this lens, that massive scale mismatch actually starts to resolve itself. The mystery isn't just that the vacuum has energy, but why almost all of it utterly fails to act gravitationally. In the GEM framework, most of those vacuum fluctuations either cancel out or they just fail to become globally admissible. They stay as raw possibility. So only a tiny, tiny residual trace survives, and that manifests as the large-scale coherence pressure we observe. I want you to consider this profound shift in our emotional perspective of the cosmos. The universe is not running away from itself. It is learning how to breathe. When we look at dark energy through the lens of persistence pressure, we aren't painting a picture of a universe mechanically tearing itself apart into some cold, dead void. Instead, we see a grand, interconnected geometry seeking a beautiful, highly natural balance. We have covered some truly profound ground today, fundamentally challenging how we visualize the void of space itself. So I want to leave you with this final thought to ponder, long after this explainer is over. Next time you look up at the night sky, ask yourself, is dark energy really some hidden aggressive substance pushing us all apart? Or are we simply witnessing the passive pressure of a live geometry, trying its best to find its lowest, most coherent state? Thank you so much for joining me for this explainer. Keep wondering and keep looking up.